Hi guys, welcome back. We left at day 9. So in this quiz we get a disk map, right? So this is the disk map which represents the layout of files and free space on the disk. Okay? The digits alternate between indicating the length of a file and the length of free space. So if we have 1, 2, 3, 4, 5, the disk layout would look like that, right? So number 1 would be one file of ID 0, okay? Then we have 2 free space, then we have 3 files with ID 1. As you can see, it always increments. Then we have 4 free space, and then we have 5 files of ID 2, okay? Now, as you can see, it always alternates between files and free space, right? And the files have a specific ID, which is just its index, right? So if we look over here, the first digit over here represents the amount of files of ID 0, right? And then free space 2, and then the amount of files with ID 1, and so on. Now, what we then have to achieve is we have to defragment, basically. So as you can see, when we have this layout, we get back this disk map, right? And this is fragmented. As you can see, we have free space between the files. Now we want to defragment this. If you use Windows since a long time, you probably know the tool disk defragmenter, right? It's actually, it resembles this stuff. And what we then have to do is we have this disk map over here, and we want from the back taking the digits and putting it in the free space, right? So in the end, we go from this to this, right? Just taking from the end and putting it into the free space. And then we just have, when we get the final disk map, the defragmented disk map, we just have to calculate the checksum, meaning at index 0, we multiply by the ID, right? 0 times 0 would be 0. Then index 1 times 0, then 2 times 9, then 3 times 9, then 4 times 8, and so on. And we have to get the sum of this, which would be 1928. So the layout I chose for this exercise would be similar to this. So we have a vector or a vecdeck, meaning a queue. So we can take from the front and the back. But it's very similar to a vector actually. And I want to have a vector which represents file and free space, okay? And the file have 2 fields, ID and size, okay? And free doesn't have ID because we don't need it. We only have size. When we look at this number over here, the first digit 1 represents the amount of digits with ID 0, right? So we would have 1, meaning ID 0 is a file with size 1. Then we have 2 free space, so free with size 2. Then we have 3 over here, meaning file with ID 1 is of size 3. Then we have 3 with size 4, meaning 4 free space. And then we have 5 files with ID 2, right? ID 2, size 5. Now, I will use a decompress function. And this decompress function will take this, basically, and it will decompress, meaning it will take, for example, the first one. And because this is of size 1, it will just automatically get it, okay? And then over here we have free size 2, right? So decompression would be then to put this free size 1 and free size 1. So 2 times free space, right? And instead of having file ID 1 of size 3, we have 3 times file of ID 1 with size 1. As you can see, it's basically the same thing, right? Over here. This is basically the same thing as this over here, right? It's just different because it will be easier then in the end to get the checksum, because we have here a vector and we can then just get the index of each element in this vector and multiply it by the ID, right? So let's see how I did that. So first of all, let's get the test input here. So let test like this, and I will copy it for the second part too. Okay. So the first thing I want to do is we want to parse this. Now I will create this struct disk map, and this has a field disk of type vectag. Okay. And this is a vectag of blocks. Okay. Now block is an enum holding two members, file, ID usize and size usize, and free with just a size of type usize. Okay. Let's also derive some traits. Clone, copy, debug, and partial EQ. Derive like this. So then I want to implement the from trait. So from string for disk map. Okay. Because we get the puzzle input as a string as usual. We return self. So let's start with disk. This is of type vector of blocks. So we take the puzzle, we iterate over the chars, we enumerate, so we get the index, then we can fold. So let's create a new vector, and let's call this block. And because of enumerate, we get back a tuple, right? We get back a tuple of index and the element. So we can do ID and size, right? Because the index will be the ID. And then because size over here is of type char, right? So we have to parse this. So a char we can parse with the 2-digit method, right? We have to provide a radix, right? So this would be base 10. We want to parse it into decimal. So if let some size, right? We get back an I32, I guess, U32, right? And then we match ID modulo 2, right? We only want every second digit, right, for the files. So the first one, then the second one would be free space. So we take the third one and so on, right? So if we have 0, then block push back. Now it's push back because we are using vectag instead of vec, but it's basically the same as pushing in a vector. And we push block file, right? Because if the modulo 2 is 0, then it's a file. And let's construct this. So ID would be ID divided by 2, right? And size we size as usize. So we divide here by 2 because we take only always the second one, right? So we leave always 1 representing the free space. So that means that the ID of that would be 0, this would be 1, and this would be 2. So we have to divide by 2 because we don't consider the free space as ID, right? So that's why we are dividing by 2. And then let's see if it is not 0, then it's free space, right? So push back block free, size would be size as usize. And then in the end we just return the block, right, the vectag. Okay, and then in the end self disk, like that. Okay, pretty easy. Then we have parse this. So let's see how this looks. Let map, disk map from test, and I want to print this out. Map disk. So as you can see over here, we then get back this vectag with the disk map, right? So we have over here a file with ID 0 of size 1, so 2 times 0, 0, right? Then free space 3 times. Then we have file of ID 1 with size 3, so 3 times 1, and so on. Okay? Exactly what we want. Now, what I then want to do is I want to call on this the function decompress, right? We have seen that before. Decompress will basically take this output we have seen and it will decompress it, right? So instead of having file ID 1 size 3, we would have 3 files of ID 1 size 1, right? But it's the same thing basically. So this is implemented for disk map. Fn decompress. We take self, and over here we take self as ownership, right? We don't take reference because we are actually returning self. So we are modifying self, so we can take it by value. Okay, so we return self, and for disk we have self disk, and we put it into an iterator. So again, we take ownership, and then what we can do is we flat map, and for each block, right, because self disk is the vectag of blocks, right, the ones we created, and then we iterate over each block, and let's match the block, and let's see if the block is of type file. We have an ID and a size field, right? So what we can do is we return a vector with block file ID and size 1, right? And the size, we put it after this symbol over here. That means if we write, for example, a slice like this 0, 5, right, we would get back a slice with 0, 0, 0, 0, and 0, right? That's why we want over here the ID, and size should always be 1, right? We are decompressing, right? So when we get ID 1 size 3, we want ID 1 and 3 times size 1, okay? And that is exactly what is happening over here, right? And then if it is block 3, we just have a size field. So back block 3 size 1, and we repeat this size times, right? And then all we do is we collect. So we collect this again into a vectag of blocks, okay? And because we are using here flat map, and we won't have nested vectors, right? So we will have this in a vectag, and let's actually look at the output, and then you will see what I mean. So as you can see, before we had ID 0 size 2, now we have ID 0 size 1, ID 0 size 1, right? And then before we had free size 3, and now we have free size 1, free size 1, free size 1, right? That is what I call decompressing this program, okay? Now, all what we have to do now is we have to defragment, right? So we have now exactly this layout over here, and now we want to defragment, meaning if we start from here, we take the 9 and put it over here, right? Then we take the other 9 and put it over here. Then we take 8 and put it here. Then we take 8 and put it here, and so on, right? Until there is no free space left between the files and free space. between the files until there is no free space, left between the files. Okay. Now, what we will do is basically we start at the first element, right? So we have this decompressed vector or vectec, and we start at the first element. So we check, is it a file? If it is a file, we will just push it over here, right? So 0, okay? Then we check the next one. Oh, this is free space. That means we have to go from behind, okay? So we have to take this one. So we take this. That's actually like that, right? And then we go back. Oh, another free space. So we take again from the back, right? Then we have 3 times 1, so we can push that over here. 1, 1, 1. And then again we have free space, so we take the 2, and we have free space, so we again take 2 times 2, right? So in the end we have this over here, 0, 2, 2, 1, 1, 1, 2, 2, 2, right? So 0, 2, 2, 1, 1, 1, 2, 2, 2, okay? And then all we have to do is we have to multiply the index with the ID. So 0 times 0, 1 times 2, 2 times 2, 3 times 1, 4 times 1, and so on, which is pretty easy. So let's create this function, which I call defragment. And we take a mutable reference to self, we return self. And let's call this disk, vectec new, like this. So we pop from the front, right? We pop from the front. So that means in a vectec we can pop not only from the back but also from the front. If we have a vectec with 2 elements, 1 and 2, and we put pop front, we get back 1, right? The first element. And we do that while let sum block. We do that until we find a block which is not a file, right? So let's do match block. And if block is a file, we don't care about the fields here, so I just put this over here. We just push, right? Push back the block. We have seen that, right? So if we have a file, this is our new vector, then we just push, right? When we have so when we have here our vector, when we have a file, we just push to it, right? 0. That's it. If we have free, then we have to pop from the back, okay? If it is block free, then we pop from the back while let sum block back. Now why am I using while let here? Because we pop over here until, if we pop from here, right, we have to pop all the free space until we reach a file, which we can then put over here, right? Because we don't want to put free space here, right? That's why we are popping until we find a file, okay? So if block file, then we push to our new vectec and we break, right? Because we found a file. So if we reach here, we pop from the back. So we have found a file, we then push it, right? We have here 0, and then we push 2, right? And then we go back where we left. So we break this loop, right? And that's basically it. So all we have to do is we return self with the modified disk, right? The disk we have pushed to. Okay. So let's call this defragment. let's again see the output of that. And as you can see, now we have defragmented it. So as you can see, ID0, we only have files, right? File, 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 and so on, right? We don't have free space between the files. And I hope these are correct. I think so, right? Let's see. ID0 size 1, ID0 size 1, then 9, then 9, then 8. Okay, let's check that. 00998. Okay, until this point we are correct, but we will see when we do the checksum, right? And now easily we can do the checksum because we have here a vector, so we can just take the index and then multiply it by the ID. So let's create the checksum method. Let's take a reference to self. We don't modify anything. This returns usize. And let's take self disk, iterating over it. We have to enumerate to get the indexes. Okay. Enumerate, and then let's do filter map. So we have index and we have the block, right? Index is of type usize and block is of type block. So then we match block, and if the block is of type file, we just need the ID. So let's then return sum I, the index times ID. If it is a free file, then we return none. We don't care about it. And then in the end, we just want the sum of that. So that means we can now call over here checksum. And let's actually sum. We can return that directly. And let's return here usize. Okay, so let's see. 1928. 1928. This is correct. Okay. I remove the input and take the real input. And let's submit that. Okay, great. Let me see the performance. Okay, 13 milliseconds. Not too bad, really. Okay, part 1 is done. Now for part 2. This is a little more difficult, to be honest. Now, we have basically the same thing over here, but this time the defragmentation is a little bit different. So what we do is we can only move files with the same ID as one block, right? So we move this over here as one block. As you can see over here, we have 3 free space. So we move these 2 9s over here. This is possible because we have 3 free space. Then we go further. Okay, we have 3 free space. So let's check for a block with 3. Okay, we have 3 files of ID 7. So we can take that, right? Then we go further. Okay, here we have 3 free space. Let's see. No, no, no. Okay, we have 4, 4. So we put this here. And then we have over here 1 free space, right? So we can take this over here, the 2, right? And then in the end, we do the same thing with the checksum, just taking the index and then multiply it by the ID. So this time, in quiz 2, we defragment first and then we decompress, right? That means we have this over here. And we leave it and defragment it with this and not with the decompressed one, right? So first we defragment with this and then we decompress to get the indexes. Now, what we want to do over here is we again create a new vector, right? And we go from the beginning. So if it is a file, then again we just push it, right? 0. If it is a free space, then we go to the back. But this time we check, okay, how many free space are there over here? Now we have 2 free space. So we check over here, is there any block with only 2 elements? There is none, right? So we can't put this over here, and we can't put that over here, right? So this is not a good example, but we have seen it like that, right? So we check, okay, the size of free space is 3, so we have to go from the back and iterate over these blocks, right? And check for size 3 or less, okay? Because over here we have 9, 9, which is less than 3. This is 2, so we push it over here, right? So we push it to the vector, right? This vector we have 9, 9. And then we continue until we have filled out as good as possible these free space with files. But as you can see, not as in the first quiz, we don't have any free space between files. We will have some free space, but not like in the beginning, right? So let map, again, we just take disk map, we parse the test input, and as you can see, we get the uncompressed output, right? So we have a file of ID 0 2 times, then we have 3 times free space, and so on, okay? Because this time we want to defragment first before we decompress, okay? So for that I will create a new method, defragment but retain blocks. Again, taking a mutable reference to self, and we return self. Again, same thing, we create a new vectag for the modified disk. And like before, we pop from the front, okay? So pop front, we match the block like we did before. So if it is a file, then we just push it to the modified disk, right? If it is free space, I will destructure it here, and I will rename this field to free, because size we will use it for other things, like that. So what we then have to do, okay, we found a free space, right? We found a free space over here. What we then have to do is we go back and we iterate over the blocks, okay? And we just compare the size of the free space with the size of the blocks. If it is smaller or equal to, we can move it, okay? So 0 to self disk length and reverse, right? We are iterating from the back. Let's put that into iter. So for each index, if let block file, so if we found a file at the back, we are just interested in the size. So self disk at index I, right? And we start from the back. So I will be in the first iteration the length of the disk vectag, right? The one we parsed. Okay, and then we compare is size, so the size of the block over here, is this size smaller or equal to the size of free space? All right, so if it is, then we can push to our modified disk the block at index I. Okay, what we then have to do is we have to remove this from the real disk, from the parse disk over here. So remove I, right? We have to remove that. because we have pushed this and this over here into the new vector. So we remove that and replace it with free space, right? So we remove and then self-disk insert at index I, block free and size, okay? So when we find the block over here, this would be ID 9 size 2, then we remove it and we replace it with free space of size of this block, right? Size 2 in this case. And then we have to free minus the size, right? So the free space over here will be then 1, because this would be 3, and we have defragmented file of size 2, so we have left 1 free space over here, like that. And then in the end, right, so as you can see over here, we have 1 free space which we can't fill in with blocks, right? So if we don't find a block which suits into this free space, so if 3 is bigger than 0, we are left with free space, then we just push into the modified vector the amount of free space, right? Size 3. Basically, the free space left, okay? And then in the end, in the modified disk, we have this over here, right? So in the end, we just return self disk, right? Then we have returned this modified disk. So let's over here defragment, but retain the blocks. As you can see, ID 02, then ID 92, then ID 21, right? So 02, 92, 2 is 1, then 3 times 1, ID 1, size 3, and so on. So we have this over here. Now what we want to do for the checksum is we want to decompress that, right? So instead of having ID 0 size 2, we want ID 0 size 1, ID 0 size 1, right? So we can just decompress, right? As you can see, ID 0 size 1, ID 0 size 1. So we have ID 0 2 times, right? And then easy, we can again call the checksum method over here. And that's it. And let's actually return all of this at once. And this is to be of type usize. Okay. 2858. 2858. All right. Nice, we did it. 4.4 seconds. Okay, it's not the best algorithm, but we got the right answer. I will see you in the next one. Take care.